Good morning to one and all present over here. I am Mr. A.G. Ignatius, Assistant Professor of IT Department, Sri Muthukumaran Institute of Technology. For the upcoming semester, I have been allotted the subject CCS356 Object Oriented Software Engineering for third year IT students, 6 semester students. First, we'll see the course outcomes. So, when the student learn this subject, what they are going to know about is first course outcome is about the various software development lifecycle models. Second course outcome is project management evaluation approaches and cost estimation strategies. Third course outcomes deals with the formal analysis on the specifications. Fourth course outcomes deals with the various UML diagrams which is used for analysis and design purpose. And the fifth course outcomes deals with the various architectural styles and design patterns which is used for drawing the diagrams. Now coming to the syllabus, Unit 1 deals with the software process and agile development. So software process means the various types of software lifecycle models which is used for in the software development process, and the agile development, that is any changes in the development process is called as agile development. Second unit tells us about how to collect the requirements from the customers and specify the requirements as a document. Third unit tells us about the software design using the UML diagrams. Fourth unit deals with testing and maintenance. After designing, we need to write the code and test the code by giving the suitable input and getting the output. And last, fifth unit tells us about the project management. How much number of teams that are needed for a project, what is the time limit to complete the given tasks. So these are the syllabus of this particular subject. So we'll see the topic object modeling using UML. So UML stands for Unified Modeling Language. It is a visual language that helps us to design the given scenario. And there are totally 8 UML diagrams that are available, and the tools which are used for drawing the diagrams are Rational Rows, which is a licensed version, and Argo UML is a open source. Now the various types of UML diagrams. First is a use case diagram, then sequence diagram, collaboration diagram, class diagram, activity diagram, state diagram, component diagram, and deployment diagram. First is the use case diagram. It shows the overall functionality of the system. The notations used are actor and the use case. The number of actors and the use case depends upon the given scenario. There can be any number of actors and the use case that can be available. And the line connecting between the actor and the use case is called as the unidirectional association. Second is the sequence diagram. It shows the interaction between the objects in the system. The various notations used are the objects, the lifeline, and the messages that are passed between the objects. Third is the collaboration diagram. It shows the interaction between the objects. The difference between the previous diagram and this one is here the messages are numbered. As you can see in this particular diagram, each and every message that is being passed between the objects is being numbered, whereas the sequence diagram will not have the numbering. So both the sequence and the collaboration diagram helps to show the interaction between the objects. Third diagram is the class diagram. This class diagram visually represents the structure of the system by illustrating the classes, attributes, and the method. The notation used is a rectangular box which has the 3 components. The first will be the class name, second will be the attributes, and third will be the operations. So for example, when you take this diagram, first class is the customer. So the name of the class is customer, and the attributes of the customer is the name and the location, and the function or the operations is nothing but the send order and receive order. Next is a state and activity diagram. Activity diagrams are used to visualize the various workflow of the activities in the system, and state diagram provide the visual representation of the flow of states in the system. Both the activity and the state diagram have similar notations with respect to the start and the stop, but the difference is that the presence of decision box in the activity diagram, which is given on the left hand side. That is, a decision box is nothing but the diamond shaped box. It is called as the decision box. The activity diagram will only have the decision box, but the state diagram will not have the decision box. Then the next one is component and deployment diagram. So this component diagram will show us will represent how the components of a system are related to each other. Now you can look into the diagram which depicts the component diagram. You can see the notation for the component diagram also. The last diagram is the deployment diagram. This diagram also shows the configuration of the runtime processing of the nodes and the components that live on them. The notation uses three-dimensional box. So both this component and deployment diagram shows the implementation part only, not the other types of functionalities of the system, and hence it is called as the implementation diagrams. Now next we move on to what is called as the concurrent model. So concurrent model means allowing the software team to represent the iterative and the concurrent elements of the process models at the same time. For example, the modeling activity which is defined for the spiral model can be accomplished by one or more of the following software actions, that is prototyping, analysis and design, combining one or more activities at the same time. Now the following diagram shows about the concurrent process models. So initially the software development process will be in inactive state. So whenever you're going to start the development process, it will be under the development stage. Then after it is entering the under development stage, it will go on to the next stage, what is called as awaiting changes. If there are any change in the requirement, that has to be incorporated over here only. Then next, after which it will be under revision stage. So after the revision stage, it will be base stage, that is, it will be confirmed. Okay, this is the final requirements, and at last it will come to the done state. So this is a typical representation of the concurrent process model. Next we go on to what is called as specialized process models. So there are two types, component based model and formal methods model. So in this component based model, the entire scenario is being divided into small components, which is called as the commercial off-shelf software components, that is COTS, and they will consider each and every model, and it will be incorporated separately, and then finally it will be integrated into one full software. In the formal methods model, there are specifically mathematical methods that is being used in the software development process. So in this formal methods, you can able to specify, develop and verify a computer-based systems by applying some mathematical notations. Next is the aspect-oriented software development, which is relatively new in this particular software engineering paradigm, which provides a process and a methodological approach. There is a methodological approach for defining, specifying, designing and constructing the various aspects. Aspects means mechanisms which is beyond the routines, which is used for development of a software. A distinct aspect-oriented process is not yet being matured, but it is in a development stage for the particular model. Next one is agile model. Agile or agility means any change that is going to be happening in your development process that has to be adapted very much quickly. So now next we'll see about the 12 agile principles. First principle is the highest priority is to satisfy the customer's requirements. We have to satisfy the customers. Second principle is that we need to accommodate the changes that is going to happen in the later stage. Third is delivering the working software frequently, from a couple of weeks to a couple of months. It should not take any time. You should follow the time scale. Fourth one is the business people and the developers must work together throughout the project. Fifth one is we need to build the projects around the motivated individuals. That is, we need to give the project to the individuals who are very much interested in working in the particular environment. Then the sixth principle is the most efficient and the effective method of conveying information is within the development team is direct face-to-face communication. That is the simplest way of communicating one's thought into another. Seventh is working software is the primary measure of progress. Whenever we are able to bring out a working model of a particular module, it will measure the progress of the development stage. Eighth one is the agile process promote constant development. A continuous development will occur then and there. Then the ninth one is continuous attention to the technical excellence and good design. We need to focus the concentration on the technical excellence and good design of the project. Then the 10th one is simplicity of the design, and we need to maximize the amount of work done. It's not essential, we need to limit the work given to the particular persons. 11th one is the team must be self-organizing. So each and every team must be self-organized for getting the best architectures and the requirements and the design. The 12th and the last principle is at regular intervals the team must reflect on how to become more effective, and it must adjust according to the corresponding behavior. Then the next one is extreme programming. So this is one of the most best practices of the agile process. So first we'll see about the XP values. First one is the communication. There must be an effective communication between the software engineers in order to convey the important information and to get the continuous feedback. Secondly is simplicity. So this XP focuses on the current needs instead of future needs. Whatever which is needed in the current situation, that has to be focused, and it has to be made, the design must be made very much simple. Then third one is the feedback. The feedback of the software product which is being obtained from the developers is very much important. It must be obtained from the customers. The feedback of the customers is very much important. The fourth one is the courage. The strict adherence to the XP practices requires courage. The courage means adapting to the frequent changes that is being happening in your development. That is what is called as courage. Then the last XP value is respect. So by following the above values, there has to be some sort of respect to the stakeholders. We have to strictly we need to follow the values in order follow the values so that we can be able to give the corresponding respect to the stakeholders. So till now what we have seen is about in this particular subject is the object modeling using the UML. We have seen what is this UML. We have seen the various types of UML diagrams which is being used. There are totally 8 diagrams. We have seen the description about each and every diagram with the help of example diagram. Then we went on to what is called as the various types of models, and at last we have seen about this XP process. In the next video we will continue the remaining portion of this particular unit. Thank you.